Kia ora koutou, Reese from QuickSense here, and today we're looking at the length of a line. Now in this question here, we're given a point and we're asked how far away it is from the origin. So let's just draw that in quickly, or very roughly. So we've got the point -3, 4, it's up here somewhere, and we're trying to find this distance here. Now all we know about this is that it is, I'm just going to zoom in over here, all we know is that it is 3 units this way and 4 units up. We also know that this is a right angle. So a lot of you out there will recognize this as one of the most famous triangles, right angle triangles. Right? It's what we call a Pythagorean triplet. So I know already that this is going to be 5. But if I don't know that, if it doesn't line up quite so nicely, how do I get that? Okay, so let's pretend we don't know the answer is 5 here. Well, what I'm going to do is I'm going to treat this as if it is a Pythagorean triangle, a right angle triangle. So what I'm trying to find is my hypotenuse. And if I'm looking at a squared plus b squared equaling c squared, then c, which is the hypotenuse, is also the distance between the origin and my point. So we're going to call that d. And that's going to be equal to, well, I take the square root of both sides. It's the difference between the x values squared, so that's a, plus the difference between the y values, and that's b. Okay, so we're mapping a to here, b here, and finally c, right? That's our distance. So what does that look like for this? Well, we know that, I'll make it a little bit smaller, the distance from 3 to -3 is 3. The distance from 0 to 4, right, that's going to be 4. And so we end up with the square root of 9 plus 16, square root of 25, which is equal to 5, which is what we saw at the beginning, or what we recognized at the beginning. In this next question, we're asked to figure out what kind of quadrilateral ABCD is. And the way we're going to do this is we're going to basically narrow down the possibilities. So the first thing we're going to look at, right, because there's a bunch of quadrilaterals, and some of them have different diagonals. So for example, this quadrilateral here, the diagonal from between these two and these two is different. Whereas some of them, like a rectangle, right, these diagonals are the same. So what I'm going to start with is by figuring out, actually, are the diagonals the same? So A, B, C, D. So we're looking at the difference between, or the distance between A and B. So diagonal, well, let's do this in blue. The diagonal between let's go diagonal AC, and the distance here is equal to, right, for all of them, x1 minus x2 squared plus y1 minus y2 squared. All right, so let's just choose, it doesn't matter which one we choose as x1 and y1, and x as the first and the second, as long as we're consistent throughout. So let's go with A being x1 and C being x2. So A is y1, which is 3, and C being y2. Well, that comes out to minus 2 minus minus 3, well that's 1 squared. Right, it's minus 2 plus 3. And then 3 minus minus 2 is 5 squared, which is equal to 1 squared is 1 plus 25, well that's the square root of 26. Didn't need to draw that so long, did I? Okay, so what about the other diagonal? The diagonal BD. Well, BD, we're going to do the same thing. We don't need to rewrite that general equation, right? We're always keeping this in mind every single time. Well, that's going to be 0 minus 5 squared plus 1 minus 0 squared. So again, immediately I can see that I've got 5 squared plus 1 squared, which was equal, same thing we had above. So it's going to be equal to 26. And the same as above, I've drawn these two long. Okay, so I know, right, this is either going to be, it's got the same diagonals, so it's either going to be a square or a rectangle. Now the way to figure out which one of these is, well, the difference between those things is that a square, all 4 sides are the same, and a rectangle has 2 sets of different sides. So what does that look like? Well, now let's look at the side AB and see what that looks like. We're going to compare that with BC. So side AB, right, the distance there, we've got minus 2, let's just put another bracket in there, minus 2 minus 0 plus 3 minus 1 squared. Well, that comes to minus 2, so that's minus 2 squared plus 3 minus 1, so that's 2 squared. Well, that's going to be equal to the square root of 8. So what about, let's just put a line down here, side BC. Now if this is also the square root of 8, then this is going to be a square. D equal to zero minus 3. And you'll notice that I'm putting all of these into double brackets, just so I don't confuse those negative numbers. So B is 1 minus 2 squared. 0 minus 3, well that's 3 squared. 1 minus, well that's also 3 squared, which gives us square root of 9 plus 9, which is 18. Okay? Because diagonal, well that's the spelling mistake, because diagonal AC equals BD, but side AB does not equal BC, this quadrilateral must be a rectangle.